So we're gonna try to have a look on question 3, which is just a special case, and I will make it its own video so that you can come back and understand it very well. So they give us an inductive circuit in parallel with a non-inductive resistor of 26. As you can see, the drawing that I put, an inductive circuit, it's only a coil, is connected across this supplier. The current through the inductive circuit, it's 8,79 as shows, and as well the current in the non-inductive is this, but the current taking from the supplier is 11,45. Okay, but what can be the problem with this circuit is that if you apply your Kirchhoff junction rule, okay, the current that is going into a junction must be equal to the sum of the current that is going away of this junction. Can you see? But if you take 11, which is going inside the junction, 45, but the one that going away is 8 and 4, something. If you add them, you're not gonna get 11, you're gonna get 12 or 13 something. Can you see? So which means there is something wrong with this problem, and the problem that can be is that we don't have angle to our current. We need to have angle to this current so that when you add them, you're gonna get the 11 something. Can you see? Because those angles are missing. So, but how do we solve this problem of angle if since they are not given? Now you remember with a pure resistor, it's always at 0, which we can say that with the current of the resistor is at the angle of 0. But with the current in the coil, remember the coil as a resistor and an inductor, it's supposed to be 90, but so it won't be 90. It's gonna be somewhere there because we have a resistor and a inductor. So the addition of these two vector here is going to give us our supplier current. Can you see? So you have an unknown here. We don't know the angle of the supplier current, so we are going to calculate it. Okay, and then if we have to calculate it, we're gonna see that we have a triangle here. We have a triangle. This side is our supplier current, this is gonna be our I coil, and then this is gonna be our IR. So you can apply your cosine formula to calculate this, and then now you apply your cosine formula, and then you substitute all the value. The only unknown is the angle, so you're gonna get our power factor angle. But remember, since our circuit is inductive already, the current is going to be lag, therefore it's gonna take an angle of negative because it's lagging. Okay, so after determining the angle to those two currents, now we can apply our junction rule to determine the coil current with an angle now. So we know that our supplier current, we got it for the resistor, we got it like this. The unknown is for the coil. It's not unknown, it's known, but we want to determine what's going to be its angle. Can you see? So therefore, when you do the calculation, now you're going to have the same magnitude for I coil, but now you have an angle to it. Okay, so after doing that, now you have to calculate now the calculation which was asked here, and then one of the calculation is to determine the value of the inductance and as well the resistance of the circuit. We were not given the supplier, but we know what is the current, okay, of the in the resistor and as well the value of the resistor. So we can calculate the voltage across the resistor, which is 94 at the angle of 0. Okay, so let's look here. As I explained the introduction of parallel circuit, okay, so we know what is the voltage across this resistor. So since the three are in parallel, which means the supply is going to be the same voltage and here is going to be the same voltage. So automatically the voltage across here is going to be the voltage across the supplier. It's going to be our supplier voltage, it's going to be the voltage across the inductor. Okay, so that's when you come down, you have to apply your Ohm's law so that you can determine the value of your inductor and resistor. It's going to be straightforward. You apply your Ohm's law, and then you get the value in polar, you change it to rectangular. This is your resistor and that is your inductance, and then you apply this equation to get your inductor. Simple and straightforward. Any question, please ask it, and it's more than welcome to be answered.